Hello student, today we are going to start with the topic integration. Integration is just opposite of derivative, or you can say that it is also called as antiderivative. Let's see the definition of the integration. Suppose we have any function f of x and we are finding its derivative with respect to x. Its answer is, assume it 5x. So definition says that integration of this 5x with respect to x is equal to this function f of x plus c, and this c is called as integral constant. So student, we are going to derive all integration formulae one by one. So we'll start with sin x. Derivative of sin x is cos x. So according to the definition, integration of cos x will be sin x. That only I have written. Integration of cos x with respect to x is equal to sin x plus c. Now we will take cos x. As you know that derivative of cos x is equal to minus sin x. So in the right hand side you are getting minus sign. So take this minus sign to the left hand side. So here you have only sin x. So integration of sin x with respect to x will be minus cos x plus c. So next term we are going to take tan x. As you know that derivative of tan x is equal to sec square x. So of course integration of sec square x will be tan x. That only I have written. Integration of sec square x dx is equal to tan x plus c. Next, you know that derivative of sec x is equal to sec x into tan x. So of course integration of sec x tan x will be sec x. That only I have written. Integration of sec x tan x dx is equal to sec x plus c. Next formula is cosec x. Derivative of cosec x is equal to minus cosec x into cot x. Since in right hand side we are getting minus sign, transfer it on the left hand side. So here we have only cosec x cot x. So its integration will be minus cosec x plus c. Next, cot x. Derivative of cot x is equal to minus cosec square x. Again we are getting minus sign in the right hand side, so we are going to transfer it on left hand side. So here we have cosec square x. So integration of cosec square x with respect to x is equal to minus cot x plus c. Now we'll take exponential function. First one is e raised to x. Derivative of e raised to x is equal to e raised to x only. So integration of e raised to x will be e raised to x plus c. Next one, a raised to x, where a is any constant more than 1. Derivative of a raised to x is equal to a raised to x into log of a. Log a is a constant, so I am going to take log a to the left hand side. So here you have only a raised to x. So integration of a raised to x with respect to x will be a raised to x upon log of a plus c. Next one is logarithmic function, that is log x. Derivative of log x is equal to 1 upon x. Then integration of 1 upon x with respect to x will be log x plus c. Next, x raised to any number, derivative of x raised to n plus 1. This is one number which can be positive, negative or fraction, whatever. So its answer is n plus 1 x raised to n plus 1 minus 1. So plus 1 minus 1 get cancelled, only n is left. So n plus 1 is constant, so we are going to take it on left hand side. So we have only x raised to n left in the right hand side. So integration of x raised to n will be x raised to n plus 1 divided by this term, that is n plus 1 plus c. Next concept is integration of x with respect to x will be what? So basically it is in the form of x raised to n. N is a number, so I can put 1 over here. So it will be in the form of x raised to n, x raised to n. So its answer is x raised to n plus 1 upon n plus 1 plus c. So I can write here x raised to 1 plus 1 upon 1 plus 1 plus c, which is nothing but x square upon 2 plus c. We are going to see what is the integration of 1. So guys, you know that in indices a raised to the power 0 is always 1. So in place of 1 I can write x raised to 0 with respect to x. So when I have converted in the form of x raised to 0, it will look like x raised to n. N is your 0. So apply this formula. So it will be x raised to n plus 1. What is n? 0. 0 plus 1 upon 0 plus 1 plus c. So which is nothing but x. 0 plus 1 is 1, so no need of mentioning it here, upon 0 plus 1 1 plus c, or you can say that x plus c. So integration of 1 is, keep in your mind, x plus c. Now we are taking some more formulae in integration, in which in place of x we have a linear function. Linear function means it is in the form of ax plus b. So if I am taking cos x, replace x by a linear function ax plus b, then its integration will be same as your cos x, that is sine of x. So this x we have replaced by linear function, that is ax plus b, but divide it by the coefficient of x, which is a plus c. Next formula is integration of sine of linear function, that is ax plus b. So its integral value will be same as your sine x, that is minus cos x, but in place of x we have to write ax plus b, but divided by the coefficient of x, that is a plus c. We are taking the next formula, integration of sec square of a linear function, which is ax plus b. So its answer will be tan ax plus b, but divided by the coefficient of x, that is a plus c. Next formula is integration of cosec square of a linear function, that is ax plus b, with respect to x will be minus cot that linear function divided by the coefficient of x, that is a plus c. Next function is an exponential function. Integration of e raised to linear function, that is ax plus b with respect to x will be same as your this term only, that is e raised to linear function, that is ax plus b, but we have to divide it by the coefficient of x, that is a plus c. Next formula is integration of 1 upon ax plus b. Ax plus b is your linear term. When we integrate with respect to x, value will be log of that linear function ax plus b divided by the coefficient of x, that is a plus c. Now we are taking the last formula, that is integration of linear function, that is ax plus b raised to n with respect to x. Its answer will be linear function raised to n plus 1 divided by n plus 1 into, also we have to divide it by the coefficient of x, which is a plus c. Now we are going to see properties of integration. First property is integration of two functions. Say one function is f of x and second function is g of x, and in between them is addition, and we have to integrate with respect to x. Then rule tells us that this integration goes to the first function and this integration goes to the second function. That only we have written integration of the first function with respect to x plus integration of second function with respect to x. Now we are going to take one example based on that. Suppose I have e raised to x plus cos x and I want to integrate with respect to x. So this is your f of x, this is your g of x, in between them is plus. The rule tells us that integration goes to the first function plus integration goes to the second function. So my dear friend, you know that e raised to x has same integral value plus cos x has integral value sin x plus c. Because now we are going to see the second property of integration. So in this property, along with the function there is some constant k. So rule tells us that while integrating with respect to x, take this constant outside from the integration. So we have taken k outside from this integration, so we have here only the function f of x. So we have to integrate this function only. For example, integration of phi sec square x into dx. So in this question, phi is a constant and sec square x is a function. So according to this property, take this phi outside from the integration. So we have here only sec square x, which is a function. So we are going to integrate sec square x with respect to x. So you all know that sec square x has an integral value tan x plus c.